just looking at the release of GPT-4o, where there's more human interaction, you do start wondering, well, you look at IQ and EQ, but again, how much of those are just algorithms that are genetic algorithms inside us that could be replicated just based on a number of cues? What is the overlap, between actually what we're doing at a sort of biological level and what is at a digital level very similar algorithms that we could put together?
The way neural networks are working at the moment is we feed them huge amounts of data and then they just magically work, right? It literally is that. No one really understands the inner workings of them. And every time we've tried in the past to understand those inner workings, this has been a very confusing mesh of millions of neurons, and it's very hard to predict how they're going to behave or how they came to an answer that they came to.
People can be very intelligent in one way, analytical, or they could be very intelligent socially or emotional intelligence. So does AI start to, as an emergent behavior, because I don't know how to train somebody mathematically to become more emotionally intelligent. There's some things you can do, but to be more empathetic, but that's something where can it think that way and then say, oh my God, humans are pretty crazy. Let's go a different way. It just sounds like that's where you're going to get consciousness, potentially.
To suddenly spark into existence. Yeah.
I mean, that's something that would be an emergent behavior. And that could be interesting. I mean, creativity, that's something where making music, art, things like that, it's just going to get better and better at that, because we don't know how to program that mathematically at the moment. So why not have that something as an emergent behavior that evolves?
It's fascinating. I'm reading a book called Homo Deus, which is the follow-on to Homo sapiens. It talks about our kind of neurological makeup, but really the base is these genetic algorithms, sort of series of steps that allow us to perform certain behaviors. And really a lot of what was interesting for me is a lot of it seems unconscious how much we're following these algorithms without realizing it ourselves. We're like, wait, we've made a lot of decisions today based on evolutionary sort of algorithms. So it is interesting to see what is that sort of, at the moment, it's not clear what makes us conscious and why we have more self-awareness than potentially other animals. There's no key component in the brain that they found. So you do wonder at what point something like that comes about. And I'm not saying, I know a lot of these sort of GPT models, they're performing a specific function, but when you do get to neural networks and, with baked in algorithms, it's interesting to sort of see, well, how much is not known and how much are we running on our own sort of program without being aware of it.
We could go pretty deep into this.
How deep do you start to say,
is dreams part of what helps with creativity? Sometimes when I sleep better, or most of the time when I sleep better and I dream, I'm just more creative and thought, those subconscious thoughts of ideas come quicker. Does that have something to do with it? Who knows? I mean, I think again, with the emergent behavior, does this get into that social kind of emotional intelligence that, how can people can be very intelligent in one way, analytical, or they could be very intelligent socially or emotional intelligence. So does AI start to, as an emergent behavior, all of a sudden, because I don't know how to train somebody mathematically to become more emotionally intelligent. There's some things you can do, but to be more empathetic, but that's something where can it think that way and then say, oh my God, humans are pretty crazy. Let's go a different way. It should be interesting.
I think it's interesting the fact that just looking at the release of GPT-4o, where I know we touched on it before, where there's more human interaction, you do start wondering, well, you look at IQ and EQ, but again, how much of those are just algorithms that are genetic algorithms inside us that could be replicated just based on a number of cues. So it's fascinating for me to see the more this I would say evolves, but the more this advances. What is the overlap, between actually what we're doing at a sort of biological level and what is at a digital level very similar algorithms that we could put together to somehow get get
I'll take a stab at a more more grounded approach to it too, just to sort of like go with that.
Always the fun of that, Joe. I'm just joking.
Yeah, I agree. There isn't, but that's how my brain's working. So I'm also thinking though in terms of emergent. Emergent means unexpected, but that could mean basically that things that we as humans see as very separate. So AI is built on pattern recognition, right? It's understanding patterns, and then as you give it information or a question, it tries to generate that response, based on that prediction. And it could just mean too that a lot of things that we see as separate that we're very surprised it can do are actually very similar in a way that our brains just don't really think of them that way. And so me taking my dog for a walk or me writing an email, as humans, we see those as very separate tasks and very separate sort of processes to go through. But the patterns behind that might actually be very similar and can translate those two different very separate tasks that we see as separate, but they're actually very similar. They come to like a similar output. Like we see, okay, our dog's back and rested. Okay, you sent the email, but pattern-wise, that can reach the same conclusion around the actual goal of what you're trying to accomplish. So yeah, just sort of thinking in terms of that way too, that maybe, it's just that we see things differently to how models see them, and things that we are perceiving as very separate tasks are actually fundamentally kind of similar in how they can be approached.
While you guys were talking, I put it in ChatGPT what they think the most logical emergent behaviors would be based on ranking of what would be first to last. Of course, the first one's adaptive learning and evolution, to complex interaction with physical environments, which, I think that makes sense with the robotic side of things. Collaborative problem solving, social emotional intelligence, unpredictable decision-making, self-improvement and meta-learning, autonomous creativity, ethical reasoning and moral judgment, resource optimization and sustainability solutions, emergent languages and communication protocols, unintended consequences and bias amplification, and then finally, self-awareness and consciousness.
That's funny.
So, there you go.
Yeah. Just the last two things added on at the end there. Self-awareness and consciousness. You might get that too, but let's see.
Don't worry about that though. Don't pay too much attention to the stuff.
No. That's all the way in the future. Way in the future. Okay, you want to jump to the next one?
Yeah, we can wrap up on this one because it's pretty small, but actually segues briefly from what Brynley was mentioned around emergent, which is unexpected behavior, but just interesting news coming out of Anthropic, the guys who built Claude. So this week they released some findings of theirs where they're basically saying that they're able to understand those neural networks a little bit better. And just to take a step back at what they're trying to accomplish, again, as Brynley just mentioned, the way neural networks are working at the moment is we feed them huge amounts of data, and then they just magically work, right? It literally is that. No one really understands the inner workings of them. And every time we've tried in the past to understand those inner workings, it's just been a very confusing mesh of millions of neurons, and it's very hard to predict how they're going to behave or how they came to an answer that they came to. And this is kind of important with AI, especially around accuracy and understanding how it's coming up with those answers, and to try and control those answers in a way is important, because if you want to release an AI, you don't want it to be certainly coming up with toxic language or giving incorrect answers, and you want to try and prevent it from doing that. And ways that have been done in the past are, because it's a black box and you can't see how it's coming up with that answer, are putting in controls that will basically, either measure the answer it comes up with, and then if it's coming up with a weird answer, it'll in the background without user realizing, adjust the parameters a bit and see if it can come up with a better answer that isn't, on a list of keywords it doesn't want you to say. It does, it doesn't want the response to say, or it'll try and manipulate it in a way that it'll keep trying until it gets an answer that's approved and send it over to the person. And same with accuracy. There'll be accuracy checks to trying to determine if those answers are accurate. But again, all of these sort of measures are put in place when the answer comes out of the model. You can't adjust the model itself easily, apart from just making lots of different models and measuring them all and seeing which one works the best. Still, it's a black box. So Claude have been looking into this, Anthropic, the Claude guys have been looking into this. And what they basically were looking at again is, it's a neural network, right? So a neural network is made of billions of, you can call them neurons almost, and they fire off when certain questions are asked. And previous attempts when they've tried to monitor those neurons, the correlation between which ones are being fired and the sort of questions that are being asked are confusing. So you could ask a question on something like semicolons, right, in C#, and you'll still get the same neurons firing when you ask questions on burritos or discuss Golden Gate Bridge, very separate, completely separate topics, but these same neurons are firing. And so it's been very challenging to try and figure out, okay, how can we predict, which neurons are even working here? What does it actually mean? So what they did, which was quite clever, is they basically, as part of that sort of technique of trying to understand it, they were going, okay, well, let's stop looking at individual neurons. Let's zoom out completely and then study groups of neurons and try and figure out, okay, can we see which groups of these neurons are firing compared to certain answers that are coming in or out, or sort of way it's generating things. And from that, they've had really good success, which means that they can actually target those areas of neurons and suppress them in certain ways or express them in certain ways, depending on the sort of questions that are coming through and the way they want to kind of mold the model into what they want it to be. So for instance, if they're seeing that a certain question was always producing inaccurate answers, they could then go inside a model and suppress those neurons that they were seeing were responsible for those inaccurate answers. And then when they reran the question, because neurons are suppressed, which basically means they skipped, different neurons would be used, which would then come up with a better answer. And so, being able to kind of manipulate the model on a neuron level rather than trying to manipulate the answer that comes out and try and fix it after the fact is huge progress, because that means that it's just a better way of actually understanding and then trying to sort of get these models into a more accurate and understandable state about how things are working. So yeah, it seems like interesting research, and it just means that the models are going to become better and more predictable, and you can engineer them better in a way that you couldn't before. And that's always been what has been very advantageous to the very large corporations like OpenAI, because they have the resources right at the moment to sort of build up all the tooling around these language models to get you correct answers and to try and come up with answers a certain way. There's a lot of manipulation that they're doing and a lot of other systems and algorithms that they're using to get GPT into the state it is, which is why the open source models haven't been able to compete very well with that, or smaller models, because they just don't have the resources to add in all the additional tooling to get it into a state. But with research like this, it means, as tools develop to actually use these techniques, you can actually modify the models pretty simply yourself and to try and massage them into a way that works better for you without having to build loads of tooling around it to try and fix it up after the fact. So yeah, just interesting sort of way that it's going there, and it's good progress. So that was really good news to see.
My limited graduate studies on neural networks that I took some of the classes on, it's interesting the different ways in which you can train neural networks. But what was always in the back of my mind is that you're hindered by the number of neurons, because humans, obviously, from what I see, we have, I think, let me look, 86 billion neurons in our brain to perform tasks, whether it's physical or analytical. Let's say a cat has 250 million neurons. And so they're using far significantly less when they're performing tasks. And, maybe their motor skills and they're much quicker, they're faster. So it's a little bit more it's more inherent into their physical structure, and they're using less. But then from an analytical standpoint, they're not using nearly as much. So their tasks that they could perform are limited. So as the hardware is getting better, obviously you start to talk about quantum computing, because the number of neurons are firing in our brain to perform these analytial tasks. Just us talking right now is in the millions. So I'm curious at how many neurons, and does that take into effect of as the hardware is improving and this actual neural network chips that we were talking about at the beginning take into account? Does that really play a factor? Because now they're evolving their architecture of the hardware to actually match what's in the actual human brain. So then that's where you're going to get some of this emergent behavior that's evolving versus just following, you program now 10,000 neurons or, hundreds of thousand neurons. But in reality, if you want the human brain, you need to have multi-millions, if not billions.
Yeah, exactly.
So I don't know, with that, is this a good time to end this episode?
I think we've gone in deep this episode. I feel like there's a lot.
I think I'm gonna go take a nap.
from Big Brother to in depth neural network analysis.
Next episode is a lot lighter.
But yeah, thanks again for everybody for tuning in and listening in. Again, like and subscribe. And thanks again. And we look forward to seeing you on the next episode.
Cool.
Right,
Catch you then.
Yeah. See ya.
All right. Bye, everybody.